In the last video, we discussed that material cost variance can be further classified into material price variance and material quantity variance. Now, this material quantity variance can be further classified into material mix variance and material yield variance. In this video, we will restrict our discussion to material mix variance. We will discuss why material mix variance is cost and how to calculate the material mix variance. Before proceeding further, please always remember one thing. A company will have material mix variance only when more than one type of raw material is used in the production. Now let's take a simple numerical example to understand material mix variance. On the left hand side, we have the standard data. The standard data is in order to produce 1 unit of output. When we say output, we are talking about finished goods. So in order to produce 1 unit of finished goods, the company is expecting to use 6 kg of raw material A and 4 kg of raw material B. So totally the company is expecting to use 10 kg of raw material to produce 1 unit of the finished goods. So here we can clearly see that to produce the finished goods, the company is using two types of raw material. One is raw material A and the other one is raw material B. So when more than one type of raw material is used in the production, we will have material mix variance as a part of material quantity variance. Now the standard price for material A is rupees 10 per kg and the standard price for material B is rupees 12 per kg. So these are all the expectations of the company. These are all the standards of the company. Now let's look at the actual figures of the company. Actually, the company produced 100 units of finished goods. The output of the company is 100 units. And in order to produce these 100 units of finished goods, the company used 750 kg of raw material A and 350 kg of raw material B. So totally, the company used 1100 kg of raw material to produce 100 units of finished goods. Now, actual price paid by the company for purchasing raw material A is rupees 11 per kg and actual price paid by the company to purchase raw material B is rupees 13 per kg. So this is the data given in the question. Now for this data, we have to calculate material mix variance. Now before proceeding further, let's understand few terms. Let's understand what do we mean by standard mix. So now from the standard data, we can see that in order to produce 1 unit of finished goods, the company is planning to use 6 kg of raw material A and 4 kg of raw material B, and the total raw material requirement is 10 kg. Now, what is the standard mix of material A in this? Total raw material requirement is 10 kg, out of which 6 kg is raw material. So what is the mix? It is 6 by 10 into 100. So it is 60%. To put it very simple, out of the total raw material requirement, 60% of material A should be used. And what is the standard mix of material B? The standard mix of material B is 4 upon 10 into 100. We get 40%. So the company is planning to use totally 10 kg of raw material to produce 1 unit of output, out of which 60% is raw material A and 40% is raw material B. Right? Now let's look at the actual mix. Let's look at the actual mix of both material A and B. Actual mix of material A. So what is the actual raw material used by the company? It is 1100 kg, out of which 750 kg is raw material A. So actual mix of raw material A is 750 divided by 1100 into 100. So we get 750 by 1100 into 100. We get 68.18%. 68.18 percentage is the actual mix of material A. Now let's calculate the actual mix of material B. So out of 1100 kg of raw material used, 350 kg of raw material B is used. So 350 divided by 1100 into 100. So 350 divided by 1100 into 100, we get 31.82 percentage. 31.82 percentage of raw material B is used in the production. So now what is my standard mix? As per my standard mix, I should have used 60 percentage of raw material A in my production. But did I actually use 60 percentage of raw material A in my production? No, actually I used 68.18 percentage of raw material A in my production. So here there is a difference between the standard mix of material A and actual mix of material A. So this difference between the standard mix and the actual mix is the reason why material mix variance is caused. Just like material A, you can see that material B, standard mix is 40 percentage, which means in order to produce output, I should have used 40 percentage of raw material B. But did I actually use 40 percentage of raw material B in my production? No, actually I use only 31.82 percentage of raw material B in my production. So the variance which is caused due to the difference between the standard mix and the actual mix is known as the material mix variance. Now let's look at the formula for calculating material mix variance. Material mix variance is equal to RSQ minus AQ into standard price. Now why we are multiplying it with standard price? Because material mix variance is a part of material quantity variance, right? And in the last video itself, we discussed the person responsible for quantity variance is the production manager. For the production manager has got nothing to do with the actual price of the raw material, right? So material quantity variance is multiplied by standard price. Just like that, material mix variance is a part of material quantity variance. So here also we are multiplying it with the standard price and not the actual price. Now we know that SB is standard price, AQ is actual quantity. What is this RSQ? RSQ is nothing but RSQ stands for revised standard quantity. Now let's see how to calculate this revised standard quantity. Revised standard quantity is equal to actual input into standard mix. So first let's calculate RSQ and then we will look how to interpret the RSQ. So RSQ, we have to calculate it for both material A and B. So RSQ for material A is equal to, what is the actual input? Actually we used 1100 kg of raw material. So this is my input, right? So actual input is 1100 kg multiplied by the standard mix for material A is 60 percentage. So 60 percentage of 1100, we get 660 kg. What does it mean? It means that if I had followed the same standard mix on my actual input, I should have used only 660 kg of raw material A in my production. Again, I'm repeating, if I had followed the same standard mix on my actual input, I should have used only 660 kg of raw material A in my production. But how many kg of raw material A did I actually use in my production? I actually used 750 kg of raw material A in my production. So material mix variance for A is equal to, what is the RSQ? It is 660 kg. I should have used only 660 kg as per standard mix, but actually I used 750 kg of raw material, and this difference should be multiplied by the standard price of material A. What is the standard price of material A? It is 10 per kg. So 660 minus 750 into 10. So 660 minus 750 gives us negative 90 multiplied by 10. We get 900 negative. I can write it as adverse variance. 900 adverse variance. Why it is adverse? Because I should have used 660 kg as per my standard mix, but actually I used 750 kg. I used more quantity. My input is more. So when my input is more for the same level of output, obviously it is an adverse variance. So material mix variance for A is adverse 900. Similar to this, let's calculate the material mix variance for B. So RSQ for B is nothing but what is the formula for RSQ? It is actual input into standard mix. My actual input is 1100 kg and my standard mix for material B it is 40 percentage, right? So 1100 into 40 percentage we get 440 kg, which means if I had followed the standard mix, I should have used 440 kg of raw material B in my production. But did I actually use 440 kg of raw material B? No, actually I used 350 kg of raw material B in my production. So let's calculate the material mix variance. Material mix variance is equal to RSQ is 440 kg. So as per standard mix, I should have used 440 kg, but actually I used 350 kg, and this difference should be multiplied by the standard price. Standard price of material B is rupees 12 per kg. So multiplied by 12. So 440 minus 350 gives us 90 into 12, it gives us 1080. So material mix variance for B, it is 90 into 12 and it is 1080 positive, or I can write it as favorable. Why it is a favorable variance? Because I should have used 440 kg, but actually I produced the output with a lesser amount of input. I used only 350 kg. So I saved this 90 kg of raw material. So it is a favorable variance. Now the total material mix variance is equal to total material mix variance is nothing but the material mix variance of A plus material mix variance of B. So material mix variance of A is negative 900 or 900 adverse plus material mix variance of B it is 1080 favorable or 1080 positive. So the total material mix variance is 1080 minus 900. We get it is 180 favorable. So this is the material mix variance.